So one thing you're going to notice as you containerize your workloads is an increased amount of network activity because previously you had this monolithic application that you're breaking into different microservices and deploying those microservices in a distributed manner using an orchestration platform such as Kubernetes. Now, these microservices have to discover each other as well as communicate with each other for your app to function. That is a lot of network activity. Now on the screen here, I have an application made up of different microservices. You can see the network communication flows between them. And the interesting thing about this is that chances are these microservices are not deployed in the same underlying host in the cluster. And depending on how your clusters are architected, they could even be in different data centers. Now, Kubernetes by default doesn't provide network level encryption. So if someone were to sniff the packets in the network, they will be able to ascertain quite a bit of information about your cluster as well as the applications running in the cluster. So let's look at a demonstration of this. Now to demonstrate this, I'm gonna run a packet capture from one of the nodes in my cluster. And as these captures are coming in, we can see a lot of application level data. Let me stop this capture. And what I'm gonna do next is run a query to look at DNS requests and responses from the Hipster Shop namespace, the app we looked at previously. Now, the reason I want to look at DNS is because this is a crucial component in a Kubernetes cluster. DNS is what facilitates service discovery so that microservices can discover each other and communicate with their peers. And as I look at the filtered packets, I can retrieve quite a bit of information about the service names as well as the IP addresses that make up the microservices for this particular application that we looked at previously. Now, this is precisely why data in transit encryption is important, even if you're running these clusters in an on-prem data center. So next, let's look at how you can enable data in transit encryption for Kubernetes using Calico. All right, so what I'm going to do next is in this cluster of mine where I have deployed Calico, I'm going to run this command to enable Wireguard encryption for IPv4 as well as IPv6 traffic. Okay. So once I have executed that command, I'm going to initiate the packet capture again. Now, as these packets are coming in, what we're able to see are WireGuard packets. We're not able to see the application level data that we saw in the captures previously. Now, if I stop this capture and run the same command we ran previously to retrieve DNS requests and responses for the Hipster Shop namespace, I'm not going to see anything. That's because at the network level, we're not able to see DNS packets anymore. Rather, what's visible to us are packets encrypted using WireGuard. Okay. Now note that we enable this using a single command, pretty much a toggle of a switch. It's that easy to enable encryption for Kubernetes using Calico and WireGuard. And if you want to learn more about this, I have included a link to the Calico open source documentation in this post. Thanks for watching.